Bohr's model of atom. Electron in an atom revolve around the nucleus in different orbits. Two. Each orbit is associated with definite amount of energy. These energy levels are numbered 1, 2, 3, 4, etc. from the nucleus respectively. As the size of the orbit increases, the energy associated with that orbit also increases. Thus, the further the energy level from the nucleus, greater is the energy associated with it. Third, as long as the electron moves in a stationary orbit, its energy is constant and does not emit any radiation. Hence, these closed orbits are called stationary orbits. Fourth, more than one stable orbit is possible for any electrons, and energy of orbit is quantized. That is, the electron revolves around the nucleus only in an orbit in which its angular momentum mvr is an integral multiple of h upon 2 pi. mvr is equal to nh upon 2 pi. M is the mass of electrons. Nu is its velocity, r is the radius of the orbits, h is the Planck constant, n is called the principal quantum number and can have integral value 1, 2, 3. N is 1 corresponds to first orbit, n is equal to 2 to the second orbits, n is equal to 3 to third, and so on. Electron cannot reside in between any two orbits. Fifth, energy is emitted when an electron jumps from an outer orbit into an inner orbit, and energy is absorbed when electron jump from an inner to an outer orbit. The energy of radiation emitted or absorbed is equal to the difference in energy of the two orbits. Factors in a favor of Bohr's theory. Stability of the atoms. Bohr's model also explains why the electron is not merging with the nucleus and the atom does not collapse. The lowest orbit for the electron in Bohr's model is the first orbit, that is n is equal to 1, and the energy of the electron in that orbit is constant. Hence, there is no question of electron falling into the nucleus. N cannot be 0. Frequency of spectral lines. Frequency of the spectral line determined experimentally are in the agreement with those calculated from Bohr's equation. Frequency nu is equal to 3.28910 raised to 15. 1 upon n1 square minus n2 1 upon n2 square hertz. Third, Rydberg constant. The experimental value of Rydberg constant are for hydrogen 109677.8 per centimeter, agreed well with that calculated from Bohr's theory 109714 per centimeter. Fourth, characteristics of the orbit. The radii and the energy of the orbits in hydrogen atom is calculated from Bohr's theory are well in agreement with the experimental values. Hydrogen spectra. Bohr's theory successfully explained the emission and absorption spectra of hydrogen atom, as well as those of single electron species like helium plus, lithium 2 plus, beryllium 3 plus. Limitation to Bohr's theory. 1. Spectra of multi-electrons atom. It fails to explain clearly the spectra of multi-electron atoms. Second, fine structure. Bohr's theory fails to explain the fine structure of hydrogen atom. Third, Zeeman and Stark effects. Bohr's theory could not account for this effect. Fourth, flat model. Bohr's theory predicts definite orbits for electrons, considering them as particles. But according to de Broglie 1924, electron has a wave nature. Bohr's theory cannot explain this duality.